Now let's continue from partial fractions. Here we have the denominator has a greater degree than the numerator. So we have to using the actual partial fraction decomposition techniques. So this example we have, which is integral x plus 1 over x plus 3 times x minus 2. This problem is really nice. It's already factored out the denominator into x plus 3 and x minus 2. So we can see that there is no repeatings. It's just a simple, straightforward denominator. So the idea is this fraction is going to come from two fractions adding together. The first fraction has a denominator of x plus 3, and then the second fraction has a denominator of x minus 2. But we do not know their numerator, so that's why we're using a and b to identify them or to label them first. And then our goal here is to find what is the a and what is the b. So if we are actually going to adding the a over x plus 3 plus b over x minus 2, we're going to multiply. We already know the common denominator x plus 3 x minus 2. So we're going to multiply the first term by the missing factor x minus 2, and then the second term by the missing factor x plus 3. But you can see that from the left-hand side and the right-hand side, they always have the same denominator, so we can just ignore the denominator and just keep the numerator, x plus 1 equal to a times x minus 2 plus b times x plus 3. Now we are going to figure out what is the a and what is the b. You can actually solving them, but here I like to using some tricks or easier way to do it. By finding the x values, will make x minus 2 equal to 0, which is the 2. So when x equal to 2, 2 plus 1 equal to a times 2 minus 2, which is 0. So I only end up with a b case. So the b times 2 plus 3, which is 5, b equal to 3. So b is equal to 3 over 5. And I can do the same thing for the x plus 3. When x equal to negative 3, x plus 3 will equal to 0. Then negative 3 plus 1 will equal to a times negative 3 minus 2 plus b times 0. So b term disappeared. We end up with negative 5a equal to negative 2. So a is equals to 2 over 5. Then we can plug in the a and b's into the original setup. So the integration of x plus 1 over the x plus 3 times x minus 2 will becomes to integration of the a, which is 2 over 5, over x plus 3, plus the b, which is 3 over 5, over x minus 2 dx. Both terms are easy to integrate, which is ln of x plus 3 and ln of x minus 2. Remember that because of the domain situation, we do need to keep the absolute value symbol for the ln's. Let's look at another example. 3x plus 2 over x cubed minus x squared minus 2x. We can see that the denominator has a degree 3, which is greater than the numerator degree 1. So to do it, our first step is to factor out the denominator x cubed minus x squared minus 2x in terms of x times x squared minus x minus 2, where x squared minus x minus 2 can further factor it out as x minus 2 times x plus 1. So we have three factors. That means we can break it into three different fractions, a over x plus b over x minus 2 plus c over x plus 1. For the a over x is missing x minus 2 and x plus 1. So I'm going to multiply a by the x minus 2 and x plus 1. And b has the denominator x minus 2, so it's missing x and x plus 1. So that's the term we're going to multiply by 2 to b. And for c, we have a denominator x plus 1, so it's missing x and x minus 2. I will use the same technique, so I'm not going to multiply it. I'm going to say when x equals to 2, x minus 2 will equal to 0. So in this version, it will eliminating the a term because I'm multiplying a 0 to the a. And also the c term because I'm multiplying a 0 to the c. So I ended up with 8 equals to 6b. So b is equal to a over 6 or 4 over 3. I will do the same thing. I'm going to let x equals to 0. So x is going to be 0. And in that version, eliminating the b and the c. So I got 2 equals to negative 2a. So a is equal to negative 1. And lastly, I'm going to let x equals to negative 1. So x plus 1 will equal to 0. In this version, it will eliminating the a's and the b to get the c by itself. So I got negative 1 equals to positive 3c, so c equal to negative 1/3. Now we're going to plug in the a, b, and c back to our setup. So the integral of 3x plus 2 over x times x minus 2 times x plus 1 will equals to the integral of the a over x plus b over x minus 2 plus c over x plus 1, where we already know that a is negative 1. And b is 4 over 3. And c is negative 1/3. And every single term is easy to find the integration or antiderivative. So we got negative of ln of absolute value of x plus 4/3 times ln of x minus 2 minus 1/3 ln of x plus 1 plus c. Remember, we're still using the absolute value symbol.